All right, so today we're going to do our Pythagorean Theorem, which we've actually talked about before, but it was a long time ago, so we're just going to kind of come at it like we haven't seen it yet. So first we're going to do the areas of the squares that we have here. So if you look at square A, how many little boxes are in there? All I'm asking you to do is count them, and please go ahead and close the computers. So square A, how many little boxes are in there? All you got to do is count. Oh, good. There are 3 on each side for a total of how many? Do you need me to help you count them? 9. There we go. Thank you. We can count. Okay. So that's 9. All right. Let's see if we can do the same thing with square B. So look at square B. All I want you to do is count the little boxes in there. There's 4 on each side, but it'd be a total of how many? All right. Somebody say it. Good. 16. Cool. And then if you look at square C, there's 5 on each side, but if you counted them all up, it would be a total of 25. Now, if you add these together, 9 plus 16 gives you 25. And so that's your Pythagorean theorem. If you square the numbers, and that's what squared is, it gives you an area, you add them together, it gives you a squared plus b squared equals c squared, which I know you've heard before. But 2 important things to remember. First of all, it is only for a right triangle. That is super crucial. It doesn't work for any other kind of triangle. And what does a right angle mean? How many degrees? 90. And you're going to have that little square in there. So first thing, it only works for right triangles. And the second thing is C has to be the hypotenuse. Do you see the little square for the right angle? See the little arrow across from it? This is your hypotenuse. That has to be C. The A and the B can kind of go wherever you want, but that has to be C. The hypotenuse has to be C. So I'm going to call this A, I'm going to call this B, but C has to be the hypotenuse, which is across from the right angle. This is your hypotenuse. Cool? Second thing I'm going to say before we just do a couple examples, because all this is sort of throwing numbers into a formula and using your calculator. We're going to talk about square roots real quick. You all passed Algebra 1. I know it's been a minute, but we're going to go over our perfect squares. Up here where it says name, I'm going to give them to you, okay? I'm going to start the pattern, and I want to see if anybody knows some of these. The first one's 4, and then we've got 9, and you're going to need to make this list. You're going to need these numbers. I'm not making you memorize them. I'm going to give them to you, but we got 4, we got 9, 16, 5 gives you 25. The next one for 6 is 36. Have you heard these numbers before? Is anyone seeing where I'm going with this? Like your squared numbers? 2 squared is 4, 3 squared is 9, 4 squared is 16. This one's 5, this one's 6. Does anyone know 7? I'm just throwing it out there to see. 7 squared? 7 times 7? If you made a square that was 7 on one side and 7 on the other, how many little boxes would be inside of it? Or does anyone just know 7 times 7 from your times tables? Yeah, you can put in your pass. I'm going to wait you out because I know you know your times tables and I know you passed Algebra 1. 7 times 7. It's 49. Good job. There we go. That's 7. How about 8? 8 times 8. 8 squared. 64. Good job. We'll go a few more. We'll go all the way up to 10. So that's 8 squared, 9 squared, 9 times 9. Good job. And then 10 times 10 is 100. You're going to need that little list of numbers because when we split up our square roots, you're going to need those. I want to hear how much you remember from Algebra 1. So I'm just going to make up a couple examples. We'll do these off to the side here. So let me just make one up. Say we have square root of 18. Yeah, I have it so 2 people can go at a time. Write this down. You're going to need to know how to do it when you get to your classwork. So square root of 18. Here's how I taught it when I taught Algebra 1. You're going to draw 2 little houses. Draw 2 little blank square roots. Now, here's what you need to do. And this is difficult, but I believe in you. I think you can do it. I'm not going to water it down for you. I think you can do this. You need to come up with 2 numbers that multiply together to be 18, but one of them has to be from this list that we made. So do you see a number on this list that you could use to multiply to get 18? I believe in you. I think you can pick it out of there. Out of this list, which one of these numbers Could you multiply by something to get 18? 9. Cool. I know you've got some number sense. 9 times what will give you 18? Perfect. Thank you. 9 times 2 is 18. Now, here's the reason we did that. And when I taught Algebra 1, I just told everybody to like scratch it off the list, is you can actually square root 9. It's not a dead-end number. We got something that works. Your square root of 9 is 3. 3 times 3 is 9. That's how we got that. So 3 square root of 2 would be the answer. Okay? I'm going to try one more. You're going to need to be able to do this to do your Pythagorean theorem. Let's do 75. So if you're going to do square root of 75, you're going to build 2 little houses. And what you have to do is come up with 2 numbers that multiply together to be 75. But one of them has to come from this list that we made. I believe in you. I know it's difficult, but I just think you can do it. Can you come up with some number from this list that you can multiply by something to get 75? It's one of these. 25. Perfect. Think like money, like quarters that you're going to put into a vending machine or something. 25 times what will give you 75? Good. If you have 3 quarters, you have 75 cents. See, I knew you could do it. Now, your square root of 25 is 5. So 5 square root of 3. All right. Let's actually do a problem and see how this goes. All right. So example 1, we got A is 8 and B is 4. We're going to label our triangle and use our Pythagorean theorem to find C. Now, this is going to be our right angle. C has to go across from it. C has to be the hypotenuse. It doesn't really matter where A and B go, but C has to go across from that right angle. So I'm going to put 8 here and 4 here. It really doesn't matter. If you want to write them the other way around, that's fine. And we're just going to put them into our A squared plus B squared equals C squared. So here we go. 8 squared plus 4 squared equals C squared. And I am going to just use my calculator. Can you all just watch while I use my calculator here? I'm going to share my screen. We're going to come over to the calculator, and I'm just going to type 8 squared plus 4 squared. You ready? 8 squared plus 4 squared, I got 80. All right, so let's write that down. We'll have 80 equals C squared. And I'm sorry, I can't have my paper and my calculator up here at the same time, unfortunately. So it won't let me have both at the same time. Probably just going to have to talk you through the calculator stuff because every time I try to switch it back and forth, my video stops working. There we go. All right, so I typed that into the calculator. I got 80. Now, do you see how we still have C squared? That's squared there. To get rid of the squared, you have to do a square root. That's why I just went and reviewed them. So when we have square root of 80, and we're going to do like the other 2 little examples I did, we're going to draw 2 little houses, and you need to find a number from that list that goes into 80. I'm going to try one more time to share my screen, and hopefully my video won't like stop working here. I can't even find my cursor now. There we go. Now, if you don't know what number goes into 80, and I kind of don't really expect anyone to, you can try 80 divided by some of the numbers on that list. Now, I happen to know what it is because I'm a math teacher and I do this all day long. So I do know that it's 16, but you could try 80 divided by 25, 80 divided by 49, 80 divided by 36, until you got one that came out to a whole number. When I did 80 divided by 16, what did I get? 5. So when you go back to your paper, please let my video still work. Perfect. We got 16 and 5. And I just used the calculator to do that. You would try 80 divided by some of the numbers on your list. Now, the whole point is that one of them works. I'm going to throw it out there and see what I get. What is your square root of 16? It's a little number. 4. Good job. So 4 square root of 5 is our answer. So that's why you have to be able to split up the square roots. And when you do your classwork, it's multiple choice. So you'll have choices to pick from. All right, try another one. This is our right angle. C has to go across from the right angle. Now this time we have C. C is what? C is 10. 10 goes there. And then it really doesn't matter what A and B are. I'm going to put A here is 3. B is the one that we're missing. So B is going to go down to the bottom. And then we're going to put it into our formula. A squared plus B squared equals C squared. So we're going to have 3 squared plus B squared equals 10 squared. And I'm just going to kind of be your calculator on this one so that I don't have to keep switching screens here. 3 squared is going to give you 9. And what is 10 squared? 10 times 10? 100. Now this one, we actually have an extra step here because we're missing B. We had C, but we're missing B. What would I do to move the 9 over? Would I add it or subtract it? Good, it's being added, so we're going to subtract. We're going to subtract 9. Again, you guys all passed Algebra 1, so you know how to solve an equation. So we're going to get B squared equals, all right, 100 minus 9 is going to give you 91. And then to get rid of the squared, we're going to square root. Now, 91 does not have a number that I can split it into. So in that case, you're done. You just don't have to do anything else. If it's not a number that will split with something from your list, then you're just finished, which is great. So just leave it square root of 91. So to get rid of a squared, you're going to do a square root. This is going good. Everybody's listening to me. Nice. All right, go ahead, flip it over. We'll try a couple more. And then you'll try a few. All right, given a triangle with sides 6, 8, and 10, is it a right triangle? Well, let's see. We're going to label these A, B, and C. C has to be the biggest number. So C has to be the largest one. So in this case, C has to be 10. So we're going to just see if it works. We're going to do 6 squared plus 8 squared equals 10 squared. And see if it's true. It's like a true-false question. Is it going to work or not? So 6 squared is 36. 8 squared is 64. We did 10 squared a couple of times already. That one's what? Yeah, 100. And then we're just going to see if that's true. Well, 36 plus 64 is 100. So did it work? Yes. So our answer is yes. It's a right triangle. Now, if you got something that wasn't true, like 80 equals 100, you would just say no. All right, so you're just testing, does it work or not? All right, and then these last ones, we have ordered pairs. So you're going to have to figure out the sides of the triangle on your own. That's a little hard, but I think you can do it. I just believe in you, all right? We want to find the length of the hypotenuse. So C is what we're looking for. We have to find the lengths of the other sides, all right? So come with me here. Do you see how this is 0, 3, and this is 0, 5? Okay, you got to notice it. I want the distance from 3 to 5. How far is it from 3 to 5? What would that give you for this side? What do you think? To get from 3 to 5. 2. Good job. 2 plus 3 is 5. That's basically what we did there. All right, now we have to get from here to here. This one's 0, 3, and this one's 7, 3. Do you see how they're both a 3? Right? So we want the distance between 0 and 7. How far is it from 0 to 7? 7. Good job. So you have to find the distances yourself. But then we're just going to put it into our Pythagorean theorem. 2 squared plus 7 squared equals C squared. So 2 squared, 2 times 2 is 4. What was 7 squared? That was the one I weighted you guys out. It's 40 something. 7 times 7. 40. Good, perfect. See, we're building our number sense. You can always use a calculator, though. All right, so 4 plus 49 is going to be 53. And then what's your last step? How do you get rid of the squared? To cancel out the squared. Square root. Now 53, again, that's a prime number, so we can't split that. It's not going to be like, oh, build two little houses and split it apart, so you're just done. That one's not going to work. You can try 53 times 25 and 53, or divided by 25, or divided by 36, or any of the other numbers on your list. It's not going to work. Right? Let's try one more. Put your right angle in there. We're trying to find C, but we have to get the distances of the other side. So let's look at these two. Do you see how they both have a -6 in them? Right? So we're not looking at that. We want the distance from 1 to 4. So from 1 to 4 is how far? To get from 1 to 4. Or 4 minus 1 is essentially what we're doing. 3. You're subtracting them. Or 1 plus 3 is 4. I don't care. However your brain wants to do it. Now, when you go this way, do you see how they both have a 1? Good. I'm glad we all see that. All right. So we need the distance from -6 to 2. That's really hard because one of them's negative. So here's what I would do. I would draw a number line, which I know is not like super fun, but it's not hard. Do you see I'm drawing a number line here? We want to go from -6 to 2, and now you can just count how far it is. You guys know what a number line is, right? You get how I did that? Okay, so now we can just count. Want to count with me? Ready? 1, 2, 3, 4, 5, 6, 7, 8 is how far that is. All right, so you can just count. Also, 6 plus 2 is 8, if you want to think of it that way. All right, so set it up in your Pythagorean theorem. It'll be 3 squared plus what? 3 squared plus... what will come next? 8 squared, perfect. Equals c squared. 3 squared, 3 times 3 is 9. 8 squared, 8 times 8 is 64. We're going to add those together. So 9 plus 64 would be 73. And then what's your last step? You want to get rid of the squared. How do you cancel out a squared? Square root. Now 73 again is a prime number that's not going to split apart. So you can just stop. But if it was one that would split apart, then you draw the two little houses, you find a number from your list that goes into it, and you simplify it.